Okay, so we're going to continue our lecture from Thursday. We're going to just continue with it. We're going to explain the concept of the least squares. We're going to determine the equation of a least squares regression line. You guys have already been doing that. Construct and interpret residual plots to assess if a linear model is appropriate. Okay, so our least squares regression line. So this is of y, which was, what kind of variable was that again? Is that a response or explanatory? Response, because there's no x in it. So y is response, explanatory is my x. Okay. On x is the line that makes the sum of the squared, and I'll talk about why it has to be squared, residuals. And then yes, going back to here, we said on Thursday, we said residuals was observed minus predicted. As small as possible. Okay, so I'm going to pause this video for a second. So what we've done is we've gone into this website here for the book. It's found on page 170. I'll put that up there. It's a student applet. You want to go to student. Once you've typed in the address that's in your book, you're going to go to the student website, and then you can come over here to the statistical applets. And what we're looking today is we are doing correlation and regression, okay? Just in case you want to do this on your own if you have no other life, okay? So what we're going to do is we're going to first draw our points. And you can put any points in. And if you notice, the correlation coefficient is my what? What would we call that? My R. Perfect. Okay. So I just put in 25 or 26 random points. It was only supposed to be 25, but we got 26. You got more for your bang for your buck. Okay. So what we're going to do first is we're going to draw our own line. Now what you guys used to do in algebra is you would just come into here and say, this is going to be my line, correct? So if you look here, if I just put a point here and I put a point here, do you want me to move that line anywhere, or do you agree with that's a pretty good line of best fit? Okay, which part's a little lower? This one right here? There? Right there? Okay. So then I'm going to come into here. I'm going to say show the least squares line. No, we're not. Okay. Now, what I wish we could show, and I wish I could go up there and record it, and it would show up on your guys' screen at home. But imagine taking a line, okay? And that line is going to be perpendicular to either the green, let's just do the green line first, okay? So if you could draw a perpendicular line, okay? Because all those points represent what's part of our data. This is where you would say the observed data, okay? The green line represents our predicted, what we're predicting happening, okay? And so the distance between that red point, any of those red points to that green line that's perpendicular, because distance is got to be a straight line, okay? And it needs to be perpendicular, all right? So that is our residual, right? Now, the cool thing is that everything above that green line we'll say is positive, right? And everything below that line is negative. Now, the crazy thing is if we go back to when we did our standard deviation, first of all the positives and all the negatives canceled each other out, and they went to 0. Okay? Guess what happens with all our positive, negative residuals? They cancel out and go to 0. So to fix that, we did what with our standard deviation? We squared it first. We've squared the difference between the x and the mean. We squared that, and then we divided it, and then we took the square root of it. That's our standard deviation. Okay? So the residual, or the least squares line, takes the residual, and guess what does what to it? We square it. So then, therefore, we can come up with, and that's what we're going to do with our residual plot here in a second, but that's going to allow us to keep things positive and allow us to see if we can actually do our linear line. Okay? So if you come up to here, so we're going to show there's the residuals that we all were supposed to have. Okay? And then the mean x and y line. So what's the mean represent again? Okay? So that's our mean of our, what's the x value? Explanatory. What's the y? Response. Okay? All right. So if I hit clear, I can come into here and I can do the same thing. What's that? All right. So we're going to draw our own line in. Actually, I want to do this first. Oops. So most of my data looks negative, right? Okay, good. So here, I'll just put it right here. What do you guys think? Which one? A little lower, so toward clockwise? You want it right there? You guys agree with Perry? Luke, you agree with Perry? Oh. Oh, wow, that's good friendship there. All right. So, no, you're right. Good job. Ah, oh, Perry. So, if I actually put it on there, right? That's not right. So there's that one, correct? All right. I think that actually you got more points. You have about the same points up here and the same points down here, right? That's my guess. Okay, now if I just let's do this for a second. What happens to our data points if I do this? So this is the original one that we just did, correct? So what are you suspecting is going to happen? So you think this is going to get pulled up this way? And this one might be dropped a little bit down? Because look at your correlation coefficient. It's positive, so that means it's got to do what? It's got to go up, but is it weak, strong? Really weak, okay? So if I showed that, right? That's pretty close to being a straight line. So that one point did what to our data? It really made it bad, right? So again, going back to what we talked about in 3.1, we know that this scatter plot is what? Non-resistant, and you can see that, right? You guys can see that? You're good? So the key aspect is that yes, it gives us a good point, but if we have one weird outlier, it's really going to throw our data set horribly wrong. Okay? Okay. So if you get bored at home, you guys can do that one. You can play around with it a little bit more. There's more applets that we're going to use that will be. And if you guys need help hooking that up, I can do that too. All right. All right. So what I need you to do, well, let's do this first. Make sure you have your calculator out. And then I'm going to pause the video because we're running close out of time. Get over there. Okay, so what we did is we're first going to calculate our data set from our SOTA question. That was on Thursday, all right? And so our data set's already entered in, right? What I want to do is I want to calculate my residual and make sure that if you haven't done it before, that you've gone through and you calculate your linear regression line first, okay? So then if I come back to my list, and I go to list 3 because that's what I need to find. I'm going to come up to here. Let's see, second list. Oh, let's try that again. There's the residuals, and I hit enter, and then the data set will come into it. Okay. And also that, if you want me to slow down the directions, it's on page 171. This is your tech corner. I can help you with that as well. Okay. Now, what this allows us to do is allows us to actually plot it. So what we did in the past, right, was we would come into here, and that is our scatter plot of our SOTA, correct? Right? Okay. So right now we're looking at that going, well, I really don't know if that's any good because I just have columns of data points, correct? Okay. So what I want you to do is I want you to hit second stat plot, all right? What I want you to do is I want you to turn plot 1 off, and then come down to plot 2, make sure that one's on, okay? Everybody have that? Okay, correct. Because my x-axis is going to be my explanatory variable, and then the y is going to be my residuals, okay? And then just so we don't run out of time, I'm just going to graph it real quick, and I get that again, right? So that, when I have something weird like that, or there's no pattern to it, that's a good thing, okay? It's bad if we get our data points that does something like this, okay? So this is my explanatory variable, and this right here is my residuals, okay? So if I get a curve like this is bad, okay? And I can't use my linear regression line. All right? So what we're looking for is making sure that we don't get a curve to it, okay? We want that randomness that appears, even if it is as crazy as what we had when we had just these stacks right here, okay? We got to remember that we were only looking at our explanatory was 0, 2, 4, 8, and 12 seconds. So we expected that column to be up there. But if we ended up with a parabola, we would have to say we can't use our linear regression line. And that's what you're going to put, is if it comes up here as a curve on your residual plot, you say we can't do a linear regression line or linear squares line, okay? Okay, so going back real quick, those are our 3 that we've come through. All right, I know we only did 1 residual plot, but we're going to work on that a couple times off, and then on your homework, hopefully if you get stuck, I can help you with that as well. Okay, so the second homework, so this is number 2 from 3.2, is going to be number 54, 56, and 58. Those 3. Okay.